NEC 300.5 addresses underground installations of wiring. The specific point of contention revolves around the required burial depth for a 120 volts, 6 amps lighting circuit serving a subdivision entrance. The disagreement arises from differing interpretations of whether this circuit qualifies as a residential branch circuit under the NEC. The authority having jurisdiction, or OJ, believes the wiring must be buried at a depth of 18 inches, presumably based on a classification other than a residential branch circuit. The alternative interpretation, supported by NEC Public Affairs upon closer review, places the circuit under 300.5:4, which specifies burial depths for residential branch circuits. The key issue is determining the correct classification of the circuit. The AHJ classifies the area as a common area, implying a non-residential classification. However, the NEC definition of a residential branch circuit is critical. A residential branch circuit is defined as a branch circuit that supplies electrical energy to lighting and appliances in residential occupancies. Several factors must be considered. Firstly, the location of the lights is within a residential subdivision. Secondly, the lights serve the residents of the subdivision by illuminating the entrance. Thirdly, the NEC definition focuses on the occupancy served, not necessarily the specific location of the electrical equipment within the occupancy. Given these points, it can be argued that the circuit meets the definition of a residential branch circuit. The AHJ interpretation seems to stem from the location being a common area, which may lead to an assumption of a commercial or non-residential classification. However, the NEC prioritizes the nature of the occupancy being served. For example, a lighting circuit in a residential apartment building's hallway would still be considered a residential branch circuit, even though it is located in a common area. Similarly, the subdivision entrance serves a residential function, benefiting the resident. Therefore, classifying the circuit as residential seems more accurate based on the NEC definition. NEC 300.5 provides tables outlining minimum burial depths for various wiring methods and voltage levels. These tables are divided into columns based on the type of circuit and location. If the circuit is indeed a residential branch circuit operating at 120 volts, then 300.5 column 4 applies. This column typically allows for shallower burial depths compared to other classifications. For instance, direct burial cables for residential branch circuits are often permitted to be buried at a depth of 12 inches, while other circuits may require 18 inches or more. The specific depth will depend on the wiring method used and any local amendments to the NEC. To definitively resolve this issue, several steps can be taken. Firstly, review the exact wording of the NEC definition of residential occupancy in the relevant edition of the code. Secondly, examine any local amendments or interpretations that may affect the application of 300.5. Thirdly, consult with a qualified electrical engineer or NEC expert for a professional opinion. Fourthly, document all findings and reasoning clearly to support the chosen classification. It is important to maintain open communication with the AHJ throughout this process. Presenting a well-reasoned argument supported by code references and expert opinions can help to reach a mutually agreeable solution. In conclusion, while the AHJ initial interpretation may be based on the common area designation, a closer examination of the NEC definition of our residential branch circuit suggests that the circuit in question likely falls under 300.5 column 4. This would allow for a shallower burial depth, provided all other requirements of the NEC are met. Always consult the latest edition of the NEC and local amendments for the most accurate and up-to-date information. In addition, consider the specific wiring method being used. The NEC provides different requirements for different wiring methods such as direct burial cable, conduit, and underground feeder cable, also known as UF cable. Each wiring method has its own set of installation requirements, including minimum burial depths, allowed uses, and restrictions. Ensure that the chosen wiring method is appropriate for the application and that it is installed in accordance with the manufacturer's instructions and the NEC. Ground fault circuit interrupter, also known as GFCI, protection is also important to consider. The fact that the circuit circuit is protected by a GFCI breaker is a positive safety measure. GFCI protection is required for many outdoor circuits, including those serving lighting fixtures. A GFCI breaker will trip if it detects a ground fault, which can help to prevent electrical shock. In addition to the burial depth requirements, it is also important to consider the physical protection of the wiring. Underground wiring is susceptible to damage from digging, rocks, and other hazards. To protect the wiring, it is recommended to install it in conduit or to use a direct burial cable that is specifically designed for underground use. The conduit or cable should be buried in a trench and backfilled with soil that is free of rocks and debris. Warning tape or other markers should be placed above the wiring to indicate its presence to future excavators. Proper grounding is also essential for safety. The grounding system should be installed in accordance with the NEC. The grounding electrode conductor should be connected to a grounding electrode, such as a ground rod or a metal water pipe. The grounding system helps to ensure that the electrical system is properly grounded, which can help to prevent electrical shock and equipment damage. Furthermore, consider the voltage drop in the circuit. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the source. Excessive voltage drop can cause lights to dim and appliances to malfunction. To minimize voltage drop, it is important to use the correct size wire for the circuit. The NEC provides tables that can be used to determine the appropriate wire size based on the length of the circuit and the amount of current it will carry. Also, consider the environmental conditions at the location. If the soil is corrosive or if there are other environmental factors that could damage the wiring, it may be necessary to take additional precautions. For example, it may be necessary to use a corrosion-resistant conduit or cable or to provide additional protection for the wiring. Remember to obtain the necessary permits and inspections. Before starting any electrical work, it is important to obtain the necessary permits from the local building department. An electrical inspector will inspect the work to ensure that it is installed in accordance with the NEC and local codes. This helps to ensure the safety of the electrical installation and to prevent potential problems in the future. Also, be aware of potential underground utilities. Before digging, it is important to contact the local utility companies to locate any underground utilities in the area. This will help to prevent damage to the utilities and to ensure the safety of workers. Call before you dig. In summary, determining the correct burial depth for the lighting circuit requires careful consideration of the NEC local codes and the specific conditions at the location. By following the guidelines outlined in the NEC and by consulting with qualified professionals, it is possible to ensure that the electrical installation is safe and compliant. A key takeaway is that while the location is a common area, the function it serves is residential, making a strong case for classification under 300.5 column 4. Always prioritize safety and compliance with all applicable codes and regulations. Always consult the latest edition of the National Electrical Code, also known as NEC, and local amendments for the most accurate and up-to-date information. The NEC is a comprehensive set of standards for electrical installations. Local amendments may further modify or clarify these standards. It is important to be familiar with both the NEC and any local amendments that apply in the jurisdiction where the electrical work is being performed. When interpreting the NEC, it is important to consider the definitions of key terms. The NEC provides definitions for many terms that are used throughout the code. Understanding these definitions is essential for correctly applying the code requirements. For example, the definition of a branch circuit is important for determining the correct burial depth for the lighting circuit. A branch circuit is defined as the circuit conductors between the final overcurrent device protecting the circuit and the outlet or outlets. In addition to the NEC, it is also important to be familiar with the relevant standards such as those published by the National Electrical Manufacturers Association, also known as NEMA, and Underwriters Laboratories, also known as UL. NEMA standards provide guidance on the design and manufacture of electrical equipment. UL standards provide safety testing and certification services for electrical products. Complying with these standards can help to ensure the safety and reliability of the electrical installation. When installing underground wiring, it is important to follow the manufacturer's instructions for the specific wiring method being used. The manufacturer's instructions will provide guidance on the proper installation techniques, including minimum burial depths, support requirements, and termination methods. Following the manufacturer's instructions can help to ensure that the wiring is installed correctly and that it will perform reliably over time. When selecting wiring for underground installations, it is important to choose a wiring method that is suitable for the environment. Underground wiring is exposed to moisture, chemicals, and physical stresses. Therefore, it is important to choose a wiring method that is designed to withstand these conditions. Direct burial cables, for example, are specifically designed for underground use and are resistant to moisture and corrosion. Conduit provides additional protection for wiring that is installed underground. When installing conduit, it is important to use the correct type of conduit for the application. Rigid metal conduit, also known as RMC, and intermediate metal conduit, also known as IMC, are commonly used for underground installations because they provide excellent physical protection for the wiring. PVC conduit is also used for underground installations, but it is less resistant to physical damage than RMC or IMC. When terminating underground wiring, it is important to use the correct type of connectors and fittings. The connectors and fittings should be listed for underground use and should be compatible with the wiring method being used. Proper termination techniques are essential for ensuring a reliable electrical connection. When backfilling trenches, it is important to use soil that is free of rocks and debris. Rocks and debris can damage the wiring and can reduce its lifespan. The soil should be compacted properly to provide support for the wiring. Warning tape or other markers should be placed above the wiring to indicate its presence to future excavators. This can help to prevent damage to the wiring during future digging activities. Regular maintenance is essential for ensuring the long-term reliability of underground wiring. Underground wiring should be inspected periodically for signs of damage or deterioration. Any damaged wiring should be repaired or replaced promptly. The grounding system should also be inspected regularly to ensure that it is functioning properly. Proper maintenance can help to prevent electrical problems and can extend the lifespan of the underground wiring. If you are not qualified to perform electrical work, it is important to hire a licensed electrician. Electrical work can be dangerous, and it is important to have it done by someone who is trained and experienced. A licensed electrician will be familiar with the NEC and local codes and will be able to ensure that the electrical installation is safe and compliant. When hiring an electrician, it is important to check their credentials and to make sure that they are properly licensed and insured. You should also ask for references and check their online reviews. It is important to choose an electrician who is reputable and who has a good track record. The NEC is updated every 3 years, so it is important to stay up to date with the latest edition. The NEC is available for purchase from the National Fire Protection Association, also known as NFPA. You can also access the NEC online through various subscription services. Staying up to date with the NEC will help you to ensure that your electrical installations are safe and compliant. The interpretation of electrical codes can be complex, and it is often helpful to consult with a qualified electrical engineer or code expert. An electrical engineer or code expert can provide guidance on the proper application of the NEC and can help you to resolve any code-related questions or issues. They can also assist with the design and review of electrical systems. Consider the specific load calculations for the circuit. While the total load is 6 amps at 120 volts, it's crucial to ensure the wiring is adequately sized for this load, accounting for any potential future increases and voltage drop over the distance of the run. The NEC provides guidelines on load calculations to ensure safe and efficient circuit operation. Also, think about the type of overcurrent protection being used. The GFCI breaker provides ground fault protection, which is essential for outdoor circuits. However, it's also important to ensure that the breaker is properly sized for the circuit and that it provides adequate short circuit protection. The NEC specifies the types and sizes of overcurrent devices that are permitted for different types of circuits. Evaluate the accessibility of the wiring for future maintenance and repairs. Underground wiring can be difficult to access, so it's important to plan ahead for potential maintenance and repairs. Consider installing pull boxes or other access points to make it easier to work on the wiring in the future. Also, ensure that the wiring is properly labeled so that it can be easily identified. Think about the impact of the installation on the surrounding environment. Underground wiring can disrupt the soil and vegetation in the area. It's important to minimize the impact of the installation on the environment and to restore the area to its original condition after the work is completed. Consider using trenchless technology to minimize disruption to the environment. Trenchless technology allows you to install underground wiring without digging a trench. Also, consider the aesthetic impact of the installation. The wiring should be installed in a way that is aesthetically pleasing and that does not detract from the beauty of the surrounding area. Consider using landscaping to conceal the wiring. When working with electricity, it's essential to follow all safety precautions. Always energize the circuit before working on it. Use insulated tools and wear appropriate personal protective equipment. Never work alone. If you are not comfortable working with electricity, hire a licensed electrician. Safety should always be your top priority. Furthermore, consult with the local utility company regarding any requirements for underground installations. The utility company may have specific requirements for the location of the wiring, the type of wiring that can be used, and the depth at which it must be buried. Complying with the utility company's requirements is essential for ensuring the safety and reliability of the electrical system. Think about the long-term maintenance costs associated with the underground wiring. Underground wiring can be more expensive to maintain than above-ground wiring. It's important to factor in these costs when deciding whether to install underground wiring. Consider the use of cathodic protection to prevent corrosion of the wiring. Cathodic protection is a technique that is used to protect metal structures from corrosion. It involves applying a small electrical current to the metal structure, which helps to prevent it from corroding. Consider the use of tracer wire to make it easier to locate the underground wiring in the future. Tracer wire is a small insulated wire that is buried alongside the underground wiring. Tracer wire can be used to locate the underground wiring using a metal detector. The NEC provides tables that can be used to determine the appropriate size of the grounding electrode conductor. The size of the grounding electrode conductor is based on the size of the service entrance conductors. The NEC also provides requirements for the type of grounding electrode that must be used. The grounding electrode must be a rod, pipe, or plate that is buried in the ground. Also, the NEC provides requirements for the bonding of metal enclosures. Metal enclosures that contain electrical equipment must be bonded together to provide a path for fault current to flow back to the source. This helps to prevent electrical shock. The NEC also provides requirements for the separation of low voltage and high voltage wiring. Low voltage wiring must be separated from high voltage wiring to prevent the risk of electrical shock. Low voltage wiring is typically defined as wiring that operates at 50 volts or less. High voltage wiring is typically defined as wiring that operates at more than 600 volts. NEC Table 300.5 16 provides ampacities for conductors based on insulation type, temperature rating, and the number of conductors in a raceway or cable. Use this table to select conductors with adequate ampacity for the 6 amps load, considering any dirting factors. NEC Article 314 covers outlet boxes, device boxes, and pull boxes. Ensure the boxes used for connections in a lighting circuit are appropriately sized and rated for the environment. If the location is prone to flooding, consider using watertight boxes and fittings. Also, NEC Article 410 addresses luminaires, lamp holders, and lamps. The luminaires used in the entranceway lighting project must be listed and labeled for outdoor use and installed according to manufacturer's instructions. The luminaires must be securely mounted and protected from physical damage. Consider the use of photocells or timers to control the lighting. Photocells automatically turn the lights on at dusk and off at dawn. Timers can be programmed to turn the lights on and off at specific times. Using photocells or timers can help to conserve energy and reduce operating costs.